Welcome to 2 Minute Science with Dr. John, where we cover a science concept in under 2 minutes. That way, if you want to watch it again, it won't take too long. Now, in this video, we will look at Newton's third law of motion. Now, Newton's three laws of motion all deal with the effect force has on the motion of an object. Now, the third law states that when two objects interact, that the force one object exerts on the second object will be equal in magnitude, but opposite in direction that the force the second object exerts on the first one. So F1 will equal F2 in magnitude, just opposite in direction. An example of this is if you were standing on the ground. So let's draw the ground here. Let's draw you standing here on the ground. Now, your weight is a force pushing against the ground. Force, weight. But the ground is pushing against you with the same magnitude of force, just in the opposite direction. Now, if these forces were not equal in magnitude, you would move. Move up, move down, whatever. Okay? But since you don't move, your velocity is constant, is zero. Okay? Which means the net force must be zero. Meaning the two opposing forces are equal in magnitude, but opposite in direction. So the force of weight is equal to the force of the ground, just opposite in direction. So we could say that the force of weight is equal to the negative force of the ground. Now, this is according to Newton's first law. Check out my video on that. Now, this also applies to two objects that aren't in contact. Now, let's say you were on the Leaning Tower of Pisa and you dropped an apple. Okay, so here's our apple. As the apple falls, okay, it's because the earth is pulling it down. The earth is exerting a force on it. But, according to the third law, the apple is also exerting a force on the earth, which is equal in magnitude, but opposite in direction. Now, according to Newton's second law, force is equal to mass times acceleration. So we could measure the mass and acceleration of the apple, and then we would know the force of that the apple is exerting on the earth, and they would be equal, but opposite. F would be equal to the force on the earth, just negative. Since the earth is so massive compared to the apple's mass, the velocity change in the Earth would be so small we couldn't even measure it, and we wouldn't even notice that the Earth was moving. So basically, most people will say that Newton's third law is for every action there's an equal and opposite reaction, or for every force there's a force that is opposing it. I hope this video was helpful. Please like and subscribe and have a great day.